In this video, we are going to discuss about the Karnaugh Map. So, on completion of this topic, students will be able to introduce with the digital domain and designing the various digital circuits like counters, registers, etc. So, Karnaugh maps are used for simplifying the real-world logic requirements. That is, so that can be implemented using the minimum number of logic gates. Here, the sum of products expression that we call it as SOP that can be always be implemented using AND gates, and it is fed into the OR gate, and the product of the sums expression leads to the OR gates feeding an AND gate. So this Karnaugh minimizations usually provides a simple and straightened procedure for the simplification of the Boolean function. Also, this provides a systematic method and it provides a manipulation for the Boolean expressions. So in this Karnaugh map, this K map diagram is made up of the squares, which each square will be representing the one minterm of the function that it has to be minimized. So in many digital circuits and practical problems, we need to find the expression with the minimum variables. We can minimize Boolean functions or Boolean expressions of 3-4 variables, but it can be easily done using the schema using the Boolean algebra theorems. That is, first one is the schema can be taken to two forms. One is a sum of product and another one is product of sum. So that is given in the two variable products. Two variable map is given here. So according to the need of the problem, the K map is the table like representation, but it gives more information than the table. So we fill this grid of the K map with zeros and ones for solving by making into the groups. So this is the three variable K map. So and this is a four variable K map. So let me say the steps to follow the solve the expression using K map. So first what we have to do means we have to select the K map according to the number of variables. Next we have to identify the min terms or maximum terms as given in the problem. Third, we have to find for SOP if it is a sum of product, put ones in the blocks of K map respective to the min terms, or else you have to put zeros. For product of sum, put zeros in the blocks of the K map respective to the maximum terms, that is one square. So make rectangular groups containing the total terms in power of 2 like, and try to cover as many elements as you can produce in the one group. So from the groups, make in the step 5, find the product terms and the sum term up to the SOP form. So from that you get to group the cells for the simplification. So this is the procedure which we have given from one cells, that is in a Karnaugh map we have to group the two adjacent cells. So form the groups and find out the product terms here. And here we will be finding out the product terms for the two variables, three variables, four variables based on the grouping of the elements. So you can find out the grouping of the elements here. So this Karnaugh also, here we are going to learn about the easy of the Karnaugh map. That is, we are finding out the min terms and the maximum terms. So easily finding out the min terms and the maximum terms, this gray code is implied by K map, and for simplification of the Boolean function, so the row and this column indicates how which is ordered in the gray code rather than the binary numerical number. So how we are drawing this Boolean expression using this Karnaugh map is, first we are creating the K map, then grouping the cells with the same value, finding out the prime elements. Next we are using the identifying essential prime elements and writing the minimized expression for don't get terms. So this is for 4 adjacent, 8 adjacent, and the simplification of this product to sum of products expression is given in this part. That is, first we are plotting the K map and placing the ones in those cells. Next we are checking the K map for the adjacent parts, and next we are encircling the parts with the adjacent ones which we are having already encircled here, and next we are combining the major parts with the ones, and next we are summing up the products. Here we can see the simplification of the Boolean function summation 3 4 6 7 0 2 4 6 6, and 4 variable map it is given here. So as I said before, first we have to find out the first we have to create a k map, and we have to group the cells with the same value. We have to identify the prime implications. Next we have to identify the essential implements here. Also this Karnaugh map has the simplification factor, finding out the came up with the number of variables. Have to identify the min terms and maximum terms. Then for SOPs we have to find out the in blocks, and next one is product of sums. Next we have to group it in a forms, and forming the group we have to make the product of terms. The possible questions on Karnaugh map are find out the cells in the four variables k map. Thank you.